Number 4 says the function f is given by 3x squared plus 1. What is the average value of f over the closed interval? Now, normally when we try to find the average of a set of data, we simply add up all the numbers in that set and then divide by how many there are. But in this case, we have infinitely many values. Just to give you a little visual of what's happening here, 3x squared plus 1 is a parabola with a y-intercept of 1. Looks something like this. I'm not going to put any more detail on that. I just want to give you a quick visual. And we're going to find the average value from 1 to 3. So if 1 is roughly here and 3 is somewhere over here, we want to take like all these points along the function, and it's sort of like we're adding them up and then dividing by how many there are. But there's a little bit of an issue with that because there are infinitely many points. We can't really divide by infinity, can we? So instead, we're going to do a little calculus to calculate this average value. Now, if I were to plug in 1 into this function, 3 times 1 plus 1 is going to be 4. Right? So this value right here is 4. And if I substitute in 3, 3 squared is 9. 9 times 3 is 27, plus 8 is 28. Now, since our minimum value is 4 and our maximum value is 28, that means our average has got to be somewhere in between there. So as we find our value, if we get something like 35 or 1 or even something negative, then that definitely means we did something wrong. So let's go ahead and go over this whole idea of average value and how we compute this if we do have an infinite number of values that we're trying to find the average of. So to find the average value of a function, you're going to integrate on the interval you're interested in, f of x dx, and then divide by the difference of the two x values on the endpoints of the interval, b minus a. If we have a function 3x squared plus 1 as our f of x, and our intervals from 1 to 3, the integral from 1 to 3 of 3x squared plus 1 dx all over 3 minus 1. Now, to take a definite integral, in other words, to evaluate this, we have to anti-differentiate the expression in here, and we'll use the anti-power rule to do that. And then we'll substitute in the endpoints here, 3 and 1, into that antiderivative and find the difference between them. So let's find the antiderivative of 3x squared plus 1. That's going to use what I'll call the anti-power rule, which is just pretty much the inverse of the power rule. So if I want to anti-differentiate a term that's a times x to the n, I need to first increase the exponent by 1, and then divide whatever coefficient you have by that new exponent. And that is our anti-power rule. So if we've got 3x squared plus 1, we'll just take this one term at a time. Increasing the power by 1 will make it x cubed, and then dividing 3 by that new number, 3 divided by 3, is just 1, and we don't really need to write the 1. The antiderivative of 1 is just x. Okay, if you don't see that, it's really like we have 1x to the 0, because x to the 0 is 1. So if we increase this power by 1, and then divide the original coefficient by that new exponent, we just get x. So yeah, we've got x cubed plus x from 1 to 3, divided by 3 minus 1. We might as well just write that as 2. And so now we're going to substitute in both 3 and 1 into that antiderivative and subtract. By the way, this evaluation is given to us with the fundamental theorem of calculus. Okay? The fundamental theorem of calculus has two main parts, and one of the parts is just explaining how we evaluate these definite integrals. So yeah, let's go ahead and do that. We're going to substitute in 3, so 3 cubed plus 3. Then we're also going to substitute 1, so 1 cubed plus 1, find the difference of those, and then finally divide by 2. So 3 cubed is 27, plus 3 is 30. So we have 30 minus 1 plus 1 is 2, over 2. 30 minus 2 is 28, and 28 divided by 2 is 14. This problem was an open-ended question. It had no multiple choices, so you will have to bubble in 14.